Okay, so let's take a look at this worksheet here and do some limit calculations. All right, so the first one here, find the limits. Starting here at 1a, limit as x approaches negative 3 of 2x squared plus 4x plus 1. Well, I actually know that this is going to be a plug-in because the substitution property tells me that polynomials can just use plug-in. But even if I didn't, I would just try it. All right, so that's 2 times negative 3 squared is 9, plus 4 times negative 3, plus 1, so we have 18, minus 12, plus 1, and so we get 7. Okay, that's it. Over here, all right, limit as x approaches 7 of 5x over square root x plus 2. Again, let's try plugging it in. All right, plugging in 7, 5 times 7 is 35 over the square root of 7 plus 2. So that's 35 over the square root of 9 is 3. And so we get 35 over 3. In C here, limit as x approaches 5 pi over 6 of sine x. Well, that would just be sine 5 pi over 6. And so if I were to think about my unit circle, I'll just draw one quickly here. All right, so there's 1 pi over 6, 2 pi over 6, 3, 4, 5 pi over 6. And so that would be radical 3 over 2 back and 1/2 up, so that's 1/2. And then limit as x approaches 0, e to the x cosine 2x. Again, this is not a difficult one because it would be e to the 0 cosine of 2 times 0, which is 0. So e to the 0 is 1, cosine of 0 is 1, so I get 1. All right, so all those were pretty simple because they were just simple plugins. All right, let's go to these. Limit as x approaches negative 4 of x plus 4 times ln x plus 6 over x squared minus 16. Now I notice that if I plug in negative 4, I'm going to get 0 over 0. Again, telling me that there's more work to be done. So I look to factor. So I have x plus 4 times ln x plus 6 over x plus 4, x minus 4. So indeed I see that the x minus 4 factors cancel out, and I can do that in the limit. And so I would just get the limit as x approaches negative 4 of ln x plus 6 over x minus 4. And if I put in negative 4, I would get ln 2 over negative 8. So there's lots of different ways I can actually write that, but I'll just write it as negative 1/8 ln 2. But that's only one of many possible forms for that. All right. So B here. All right, limit as x approaches 2 of x cubed minus 8 over x minus 2. Initially, I would get 0 over 0 here, and I would need to factor. Now, I don't offhand remember the difference of 2 cubes. So what I would have to do is I would actually have to do a long division here. I'd have to put x minus 2 into x cubed minus 0x squared minus 0x minus 8 and do the long division. So x would need x squared to go into x cubed, multiply that out, x cubed minus 2x squared, subtract, I get positive 2x squared, okay, and then bring down the minus 0x, x to 2x squared, I need a plus 2x, and multiply that out, 2x squared minus 4x, subtract, and I would get 4x, bring down the minus 8, x to there, I get a plus 4, 4x minus 8, 0, as I should get a remainder of 0 because I know x minus 2 divides x cubed minus 8, because 2 gives 0 for x cubed minus 8. And so what I have is that this actually factors, so I have the limit as x approaches 2. I have x minus 2 times x squared plus 2x plus 4. Separate that. Over x minus 2, and as I expect, x minus 2 cancels. And I just get the limit as x approaches 2 of x squared plus 2x plus 4, which now is a plug-in. 2 squared is 4, plus 2 times 2 is 4, plus 4, and I get 12. Okay. All right, how about this limit here? So again, in C here, if I plugged in 0, I'd get 0 over 0 again. But this one, I know, is my classic radical conjugate. So I'm just going to multiply by radical x plus 5 plus radical 5 over radical x plus 5 plus radical 5. So get the limit as x approaches 0. So when I multiply that numerator, a squared minus b squared, so I just get x plus 5 minus radical 5 squared is 5 over x times this whole mess, x squared x plus 5, which the top cancels to be just x, and then I have x, and then this numerator term, denominator term, x plus 5, cancel, and once again, I've canceled out the thing that was causing the 0 over 0. I get the limit as x approaches 0 of 1 over radical x plus 5 plus 5. I can plug in 0 now, and I get 1 over radical 5 plus radical 5, or 1 over 2 radical 5. Okay? Now, okay, when I see this is a 0 over 0, but what it is that special limit. So this is the limit as x approaches 0 of sine kx over kx being 1, but I have to manipulate it into that situation. So basically, I'm looking at it like this. I have a sine 3x over 2x, but I'm going to bring the 2 out here like this. All right, so that's the same thing. But what I want to do is I want to make sure I have a 3x under the sine 3x. So I'm going to put a 3 in there and a 3 up there. That's 1. So now, once I do that, I then have the limit of a constant times the special limit that I know. So the limit of the constant is 3/2 itself, and the limit of this special limit is 1, because its the limit as x approaches 0 of sine 3x over 3x. End result, 3/2. Okay. All right, so this is interesting because this is something that we're going to be doing in the future. Right now, I want to do it just as an algebraic limit exercise. But what we're doing here is actually something that later on is going to be essential to us. It's going to be the derivative, but this is just a look ahead. All right, so all I want to do is, I notice that I have f of x is x squared minus 4x. So that means that f of x plus h would just be putting in x plus h everywhere for x. So that would be x plus h squared minus 4x plus h. So that right there, I'll put it in brackets, is just f of x plus h, minus f of x itself would just be x squared minus 4x. Okay, and then over h. So we have to multiply this out. Okay, and so we can get x squared plus 2hx plus h squared when I FOIL that out, minus 4x minus 4h minus x squared plus 4x all over h. Notice we're taking h to go to 0, not x here. So the x squareds cancel there, the 4x's cancel, and what I get is a 2hx plus h squared minus 4h over h. Okay, interesting. It doesn't seem like anything can cancel right now. I was looking for something that is causing a 0 over 0, because actually I skipped that step, but in the beginning realized that if you put h of 0 in, you would get 0 over 0. But notice I have a common h factor on top. Whoops, that should be h. So that's h times 2x plus h minus 4 over h. Now the h's cancel, and I get the limit as h approaches 0 of 2x plus h minus 4, which can now be evaluated, but realize h here is going to 0, not x. H is going to 0. So that h there goes to 0, and I'm left with 2x minus 4. Okay, we're going to be doing more of those later, but that was just a little foreshadowing to type of problems that we'll be doing soon. Okay, so now these true or false. All right, limit as x approaches 0 of absolute value of x over x equals 1. All right, that's false, because that's the function that actually looks like this. Okay, so that's the one where the side limits don't agree. The limit from the right is 1, but the limit from the left is -1. So false. If f of x equals g of x for all real numbers other than x equals 0, and the limit as x approaches 0 of f of x equals L, then the limit as x approaches 0 of g of x equals L. True. Those are two functions that agree at all but one point. And if they're the same for every other point, then the limits of that excluded point must be the same. Finally, if the limit as x approaches 0 of f of x equals L, then f of c equals L. No. Remember, we said that there is not a automatic connection between the limit and the function value. So it might be, but it might not be. We're going to see later on, this has to do with continuity, but it isn't a fact of the limit itself. So that would be false. Okay. All right. So those are some more problems on calculating limits.